So when we integrate trig integrals that are powers of tangents and secants, we're going to do it in a way, at least we hope, that it's going to be similar to the powers of sines and cosines. Now, the pairing of secants and tangents, the reason for that has to do with the derivatives, okay? But to do this in a way similar to sines and cosines with odd powers, it's going back to that identity, the Pythagorean identity, and just then dividing both sides of this by cosine squared of x to get tangent squared x plus 1 is secant squared x, or solving that for tangent squared. And so this allows us to either change secants into tangents or tangents into secants, but they come in pairs again. Okay. Now, one thing that's going to be different though than when we did this with sine and cosine is we need to make substitution, that we're going to eliminate trig functions. And with sines and cosines, derivative sine is cosine, derivative cosine is negative sine, so we needed that singleton sine or cosine left over. Here it's a little different because the dw that we're wanting is going to be the derivative of the other function. So if we're going to make a substitution, let's say w be tangent of x, then the dw would be the secant squared. So we'd actually want a pair of secants left. And in a similar manner, if we're going to let w be secant, we'd actually need a secant times tangent left over for the dw. So that's what makes this a little different, but that's what you then seem to need to look out for to have left over. So as an example on this one, here we're going to be taking our integral of tangent squared of x times secant squared of x. And right away we can see here, oh look, there's a secant squared. Right? This makes a perfect dw already, right? We want that to be the dw. Well, it's going to be great because all we have to do then is let w be tangent. So that's our substitution in this case. W equals tangent of x, and then your dw, as we said, was secant squared of x dx. And so rewriting this, tangent squared is now w squared. And the rest of this is dw. Antiderivative, 1/3 w cubed plus c. And then, of course, the w is really a tangent. So it's 1/3 tangent cubed of x plus c. So that one is actually quite simple to do.